Suraj Singh, Civil Engineer, IIFI, International Professional Engineer, Chartered Engineer, Buildings, Fields, Oil, Gulf Experience, Writer, and whatever you can say. Building practice, Civil Engineering Building Practice, released 1996, started 1992. Practical 1 completely, no theory. Practical aspects, activities, contracts, project management, state of art, and practical work required to be learned by a fresher, budding, and all those. Good morning, Suraj Singh. Every day, usually when I have a chance, I talk to you about various issues, including engineering, field engineering, national issues, our country issues, other issues, usual talks. I like to interact with people, which is my passion, because there is nothing left. Better to give to people whatever you have, irrespective of considering proceeds. Proceeds is not my problem. My problem is promotion of knowledge. Promotion of knowledge is very important point in professional person. Professional means we are specialist in certain way, specialization in certain field, advanced knowledge in certain field means profession. People sometimes even do not understand meaning of what is profession and what is professional. One meaning of profession is that you are professing certain religion, you are professing certain faith. That is profession. Another profession is that you are a talker, you are a writer, or you are a lecturer or professor. That is also a profession, but that is professional teacher. When I am talking of profession, it's profession of whatever branch, whatever specialization. I am talking of profession of engineering, in which you will learn engineering, you apply engineering, you experience engineering, and then you become an engineer, a reliable engineer whom trust can be given. That engineer is known as professional. Means that person must have a degree, not academic degree I'm talking, degree of application, degree of confidence, degree to deliver work, accurate work, quality work, and of course timely work. That person can be called an engineer who understands all pros and cons of work he does and delivers. Management of works means academical management, theoretical management, application management, and other management criteria such as codes, laws, statutes, everything. The basic structure is cost is important, timely delivery is important, and quality is important. Quality, time, and cost. This triangular management must be made up, must be upheld by all other supporting structures. That person who can do all this independently, whether for some big project or for some small project, is called professional person in engineering. It can be chartered engineer, it can be professional engineer, or it can be otherwise, who commands knowledge in engineering, who can proclaim that whatever is done has been done meeting all required criteria, and that work is called professional work, and it takes time, It takes years to become professional. It's not simply that you come out of your university, you are professional. That is only professional education you attained, not more than that. Even if you attain 1 year or 2 year experience, it doesn't make you professional. Professional means you must have complete command, you must know what you have done, you must know what your errors, and you must know where you did correct. That's called profession. I am based on my experience in building structures, in oil, in office engineering, on site engineering, in writings, technical management. I have miscellaneous types of experience. I am claiming none because there is no meaning of claim. Sometimes I have seen people claim, but then they cannot prove it. During probation, they yield. That is not required. If I claim something, I should do that. When we write our CV, we write so much in that. I have done this, I have done this, I have done this. But when I talk to them, they won't answer. And if one is competent, shall of course answer. Just writing titles is meaningless if you cannot do that. Same thing applies to me and to you and to everyone. Don't overestimate yourself. Just keep silence with details in mind, and when required, speak out, write or do. And that must be reserved, not simply boasting all time. I have done this, I can do this, I shall do this. Boasting is not required in profession. Competency means you should produce it. You should be capable to do that with consistent approach and with reliability, not with haphazard work or with hit and trial and error. That's not required. So profession has different meaning. Profession means an advanced knowledge in whatever branch you are, in whatever subject you are, mastery you are. That is called advanced learning. Advanced learning, if you are, it doesn't matter which degree you have, which post-graduation or master. How much you have totally learned, that is called profession. Profession brings a responsibility. Profession brings liability. Profession brings accountability. All you have to do, because you are not poet, you are not story writer, you are not novelist, you are not film star, you are not cricket star or football person. You are going to spend money of other people on material, human resources, machines, and all whatever is required. That is money, that is wealth. And we cannot risk natural resources to be wasted. We cannot risk human resources to be wasted. We cannot risk a world of potential to be wasted. Once you waste material, you cannot take it back. You cannot retrieve it. And we should not forget whatever material we are using in our engineering field, that is mostly inorganic. There's a difference as a doctor and as an engineer. A doctor treats on organic materials because body is organic, whereas engineer does not deal with organic materials because building is not organic, structure is not organic. Structures are produced using materials such as concrete, steel, timber, aluminum, structural steel, whatever is that. And these materials are not organic. These materials cannot decompose. Medical science deals with body, which is organic, where organic materials are more important, but in engineering, organic material got no place. We say there should be no organic material, there should be no impurity like that. That's what engineers require and use. Your material cannot decompose, steel reinforcement cannot decompose, structural steel cannot decompose, concrete cannot decompose. Of course, this can be deteriorated in long term due to external agencies like corrosion, like carbonation, like whatever else. But there is no decomposition. It cannot change its chemical composition, it remains there. This point we have to understand. And that's why engineer needs lot knowledge. Lot knowledge of materials, material science we call it. That knowledge is very important. Natural knowledge is very important. How sun affects, how wind affects, how water affects. So profession is multidimensional. It's not one dimensional. It starts from imagination, a conception, a dream. Of course, you may call job of an architecture, job of an engineer, whatever, it doesn't make a difference to me. But that's a part of profession. You have to start an imagination. Then you convert it to the development of that imagination. You try to bring it on a piece of paper and then start from the real engineering. Physical engineering, you can say that imaginary engineering, hypothetical engineering is converted to imaginary, and then to physical engineering on paper, and then can try to bring it to designs and then further in execution or prosecution. That's our cycle, and many people fit one place and many people fit other place. This goes on. What I'm talking is of physical engineering. I'm talking of work in field. Work in field, you may call it's not issue. No, it's an issue. Work in field is more important sometimes because whatever is done in designs, that is generally done in office. That is generally done in office, and sometimes those people who involve themselves in designs give themselves distance from market availability, from practical availability of materials and resources. They're not very clear on that. Sometimes, I'm not saying always. Those who are pragmatic, who are experienced, they may know at certain location, not throughout world as you know, but the person who is on ground, who is on location site, he has to work out. There should be a match, there should be a coordination between both person in design and person on ground or zero or site. If both do not talk each other on paper, both have different pages, it's very difficult really to work because ultimate target is work. Realization of that imagination, that design which was put on paper and is to be reproduced in reality, in physical form, on location by that person who is on site, who did not have that idea what you had during design, and you don't have idea what idea the person would have while working on site. That's a different class. That's called management control. We have to ensure whatever you design must be done. How that person thinks on site, how you thought, conception stage, both are different. But both should not be different. Target should be the same. That is the reason. It's not layman job. People say site is layman job. Many I have in my career. Oh, this is layman job. We are doing design. We are intellectual. This foolishness must go. You are doing on paper and they are doing in reality. You are doing in air-conditioned room and without air conditioning, you are doing in comfortable room. They are doing in all weather conditions. That's the difference. You stand and see in 45-degree temperature, see how work is done, how can you touch steel, how can you handle steel, then you will understand how can you handle concrete. You are sitting in room designing in computers, and you cannot say that those people are easily working. There's a lot of difference. You are thinking 8 hours of 8 hours, they are thinking 3 hours of 10 hours. There's a difference. Because they are doing manual work, sometimes 4 hours a day, standing in sun, going here and there, fighting with people, quarreling with them, producing material, pulling, managing material, managing resources, that we are doing. That also is different nature. They are handling with certain things without which you cannot produce job. You're handling on software, you're handling on thoughts and formulas. And there's a difference. We have to understand this, and we have to close this gap between design and site. That gap is more important because this is to be gulfed, bridged. This bridge is very important. This is called coordination, this is called interaction, and this is called making clear misunderstandings. And that is purpose which I am interacting with you about site activities. Do not take it otherwise. Purpose is same. One is project imaginer, and other one is project producer. Both are there. Activities are very important. I have talked so far about triangular management. in which one corner is owner, that is called promoter, or client, whatever you name. Other one is engineer, who is responsible for all controls, design controls to delivery control, and other one is contractor, who works according to designs and documents given to contractor and delivers that meeting all compliances. These three persons are there, and of these three persons I explained before also. Owner is totally accountable, and owner takes risk, safety risk, quality risk, market risk. And engineer is a person or a company or what you can say who designs, surveillances, supervises, and supports all for project, whereas contract is a person who converts all these details to physical form at his own risk and designs. And there are, you can say, relevant staff with them. You can say engineer is a staff, although staff is paid, fee paid or whatever, but engineer is independent of these two as far as authority is concerned. That authority and power is very important because that guy has to certify, whereas contractor is responsible if there's a construction contractor in all respects of construction. And if that person is EPC, is engineering, procurement, and construction contractor, then design also falls within that responsibility obligation. Here, generally, I'm not entering into designs in these talks because design is very different field. You need similar type of audience who can understand design. I'm talking those who consider themselves or others consider them laymen. I consider myself layman, a blank man who knows nothing, just talking how we work in field, how we work on ground. That's what I'm talking about. And this talk is actually communicative talk. If you listen, if you understand, if you can take benefit from it, it's up to you. And if you think this man only barks and goes away, okay, no problem to me. I am trying to give you something. If you're not able to receive it, that's your choice. I am not losing anything. I am trying to do this as a professional and social service for those who are budding, who are learning. If they can benefit even 5% of it, I think I'm okay. It's very difficult to receive something which requires your mind. You receive something physically very easily, but if you want to use your mind and receive something by mind, isn't that easy? It's not that easy. If it's so easy, everybody can be educated. It's not that easy. Money can be received, but knowledge cannot be received very easily. You have to keep that in mind because concentration is required, temperature of your mind is required, your dedication is required, and you have to lose your sleep to learn something. If you do not lose your sleep, you cannot learn anything. You go on sleeping, nobody will help you because sleeping is very good, very comfortable activity. It helps you, but losing a sleep is very powerful activity. You sleep less, you will get more and more. Well, choice is yours. No one is forcing you and no one should force you. This is engineering, means this is social development, this is national development, this is world development, without which nothing is going to happen. And it takes years and years and decades to develop something because forests and deserts are to be converted to cities. That is more important. There's a forest, just imagine you are standing in a forest one day and there's another day when you see you are standing in the same place in a city or in a palace, you can realize difference. What it was when you were standing in the wild, in the forest, the deep forest, and one day you find yourself in the same area, relocate to city. That is what is called engineering. And all engineering disciplines are involved here. Imagination goes to physical work. How much work has been done, you have to imagine that. How many resources were used there, how many activities were undertaken, and how many changes have gone, how much natural resources we see. We are natural resources we are using. It's not our created resources. It's natural source, natural power. We are excavating earth. We are mining. We are taking out aggregates from there. We are taking sand from the air. We are taking steel from the air. We are taking aluminum from the air. What we are not taking from the air, that's to be thought of. It's nature after all. It's earth. We are using that for our development. We are doing nothing actually. We are just taking out that and using it. That is called engineering. We have to see what is best for us to be used, how best we can use, what's optimum level we should use, how long it can be used, is it reconvertible or not reconvertible. That's what we have to see. We are taking millions of cubic meters of aggregate and sand and lime and silica, all that we are taking out from this earth. Tons of steel, millions and millions tons of steel, ores we are taking out. We are taking out only, we are not giving anything to us back. Are we giving something back? No. We are just taking out from whatever source. Take out petrol, take out diesel, take out aggregate, take out steel, take out aluminum, take out gold, take out everything and leave hollow there. We are leaving hollow there. Just imagine how many houses and buildings and structures have been constructed in the whole world. How much metal we have used? Is that not a question? This means we have already destabilized Earth. Its equilibrium is already disturbed. Well, that's entirely different talk. Just to refresh your mind, I'm telling this, that we should be reasonable. We should be responsible. We have a responsibility to our society, to our world, that we have to keep air free. We have to keep Earth free from disturbances, from impacts. But we are not doing that. We have to minimize our use in construction or development, but we have to meet our requirements. So I was talking in last one about responsibilities, what these professionals are required to do, what resident engineer is required to do, what engineer is required to do, what contractor is required to do, contract resident, contract staff has to do, or site agent, site engineers, project coordinator, all that. These responsibilities I talked of, site engineer, resident engineer, all that. Now I am going to something else today because we have to move further and further. We cannot stop at one place. I talked about some formats last time. Now I'll just go on to activities. Activities for construction of, let us say, reservoir type swimming pool below ground. Do you know swimming pool? I'm sure everybody knows it. I'm just giving the basics of it. There are so many designs of pools. I'm not going to think about that because when I produce certain pools myself and I learned from that long back, I just want to share with you that one. It was for construction of a swimming pool. Now, what I will tell that is before proceeding for construction of swimming pool, we have to make sure that all working and coordinated drawings have been approved and these are ready for use. So now for that, what I have written, making or setting on number one could be there's a ground available where we have to construct swimming pool. This is setting out of central line and establishing a benchmark and approval of setting out works details on ground by resident engineer or by yourself. Means I'm just forget now resident all that. I'm saying this activity. I'm talking about activity. So it has to be approved by someone. Resident engineer say excavation of required area, including working area approximately 1.5 meter to 2 meter around hole excavation of dimension. Actual dimensions you have to add area 1.5 to 2 meter all around because depth is there. So you need more work area. Around pool area depending on nature of soil which has to be excavated. That means it can be rock, it can be soft soil, it can be hard soil and whatever. Then keep a control on levels of formations. I'm little speaking differently because there's some problem here. I think some problem in my throat, so take it different. Don't take it. Maybe I twist my tongue. I'm feeling the pain. Well, keep a control on levels of formations constantly. and means level form. You have to keep level controls during excavation constantly and reach nearest levels. Probably massive earthwork in excavation should have been carried out by use of earth moving machines, that's called excavator, except last or termination part or dressing part of earthwork, which usually be dressed manually according according dictation of formation level profile or direction of formation level profile. Now prepare profile surface. Profile surface means whatever design is given. I'll show you sketch. Prepare profile surface for laying blinding concrete on compacted earth. Let resident engineer inspect compacted uncompacted base and obtain approval. Because I am giving this, the contract is working, that's why Reginald Reyes is coming into this picture. And before moving further, I just want to give a sketch of this. People just discover it from where I included. It was included somewhere. Let me see if I can find it immediately so that you should know what I am talking about. That is very, very important one. I think because I collected sketches in this book at what location, no, not on a page. So I should be clear about that where this is. I'll try to get, I think, mhm, maybe I'm not able to get that so quickly, yet it should be there. I'll try to find out. These activities are, of course, very, I don't know. These activities are, of course, very, very complicated, and you should not dream of that. You should be clear of that. That is important. I'll show you maybe somewhere I'm near. No, it's not that. I'm wasting your time. I'm wasting your time. I'm sorry for that. I should have ready before. I cannot find it. Yes, I got it. I got it. I got it. Yes, swimming pool. Yes, 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 yes. Before this 100. Okay. I'll give you a sketch now, which is very important from your understanding point. Now, I'm going to use pool shelves now, first of all. This is a hand-drawn sketch, 25 meter by 13 meter, finished size. This is swimming pool, layout, and services typical. This is plan, or they call it shelf of swimming pool. One and is deep one, other one is shallow one. There is a slope in between, and there is one recharge, or you can say balance tank. So one part is shelf, one part is balance tank, and there's a ring main around this for services, and there are other facilities here: changing room, pump room, all that is there. We'll discuss in the activities. My purpose is only to show you what I'm talking about, and if you go there, you'll find another one sketch here. And then that is this one. This is your sketch. It's all drawn by me long back, It was 1986 or I think 86, yes, 1986 or 87 drawn. In those days by pencil and by graph paper by other people, manually used like a draftsman. Of course, I was there, draftsman, I was the engineer, I was the manager, everything got here. And this is that one. Now I'll go back because you're just lonely crowd. I'll go back to one of them. This is so I continue my talk. Yes. So we come back. And I'm speaking now from this. Don't take it by voice. Mm, mm, Yes. So now as a keep a control, I said, and I said prepare profile, surface profile. I have shown you what sort of profile is required. Prepare profile surface for laying blinding concrete on compacted earth and let engineer inspect completed base and obtain approval for blinding. This is one part. You know, field test, the test must be there, everything must be there before that. You cannot simply say, because this was rock one, so there's no major problem. It's not rock one. No, fix elevational marks for reaching top of blinding concrete. Means during your dressing work, you cannot dress to below or you cannot dress to above that level. Because if you excavate more than formation level, you cannot backfill that. Such backfill is not permissible. If you backfill, that is against specification, but people do that, I know. But if it is there, you have to cover it with blinding concrete only. At that point where there's more excavation, you have to use blinding concrete to cover that depth. And if it's more than formation level, above formation level, you have to remove that. So both ways you are looser. Therefore, level control is very important. Now, fix elevation marks for reaching top of blinding concrete. I said blind surface to obtain a smooth surface topping. Blind surface means you are laid concrete. Blinding actually is very weak concrete. Generally M20 we call it. That is M20 you use for blinding surface, which we call it in Bharat, India we call it lean concrete, but blinding means we are blinding all bad spots. That's meaning of blinding. There are many voids, pinholes, others which are generally happening when you excavate. There are so many ups and downs, uneven layers, and compacted. Of course, we compacted that, but even after compaction, you cannot get same level and same profile. There are holes, no holes, depressions. To cover all that, we want to blind those openings. We have to blind the holes. That's why we call it blinding concrete. Means you may take a different way, it doesn't make a difference. Question is you have to start job. That's actually called formation level. So you are working on formation level and you are working to your structural start level. Then you go to mark profile of rafts because it's raft. It's complete structural base. Mark profile of raft and all central grid lines so that marks are visible as projected, having raft been poured, laid, references transferred for work feasibility. We are working on that base, prepare base, over blinding, and it's a raft, complete concrete, continuous concrete. It's a shelf, which is a concrete base and concrete walls all around, and that work you are starting. So I am explaining to you about RCC shelf, RCC swimming pool shelf, which constitutes as comprises of RCC base and RCC walls all around. This is an important talk. It's very specialized work. You cannot leave it to some person who cannot understand. There shall be water seal in this. Water chances are there to leak. That point requires to be considered within this. Is a structure having different heights of walls, deep end walls, and you can say shallow depth and deep. Both are there. Balance tank is there. Lighting arrangement is there. Circulation of water is there. Changing room is there, and other facilities are there. Overflow is there. All these points have been covered in this design, and I am talking of activities which are involved to construct it. So I said, mark profile of raft and all central grid lines. Grid lines mean to say on drawing you have been given A, B, C, D, E, F, G, H on x-axis and 1, 2, 3 or something like that. A, B, C, D on x-axis and 1, 2, 3 on y-axis, all 5 meters spacing or whatever spacing is there, that are called grid lines. If your drawing has got fine, if your drawing doesn't have, that I cannot help it. It depends upon architect or engineer how they produce it. Check details as supplied. The check supply details in shop or working drawings by swimming pool supplier installer. Because this drawing comes from swimming pool supplier, of course. Whether intake water pipe system shall be laid in portion below raft or to be laid in raft structure as generally are laid in raft. And talking of supply pipes, intake pipes, I speak again. Check details supplied on shop drawings or working drawings by swimming pool installer or supplier, whether intake water pipe system shall be laid in portion below raft or within raft structure. Then should system be laid in raft structure? You are keeping that intake or supply in raft structure. Proceed for waterproofing system as supplied, as specified, that is spreading bitumen membrane layers duly overlapped and make surface durable, and let that be inspected and approved by whosoever resident engineer, and then proceed for applying waterproofing protection layer, that is membrane or a coat, that is a coat of 25 mm thick cement mortar on ratio of 1:3, so that bitumen treatment system be protected during preparatory and pouring operations of RCC craft. Means you have to apply water protection, waterproofing. We call it waterproofing. Actually, it has different function. Actually, not waterproof alone. It's one part is waterproof, and also it is soil protection. Protection from soil, from chemical impact of soil onto concrete. Soil contains sulfates, soil contains salt, soil contains so many chemicals, adverse chemicals, which can harm concrete, structural concrete. For that purpose, this bitumen layer works. So it has both function, waterproofing as well as chemical protection from effect of soil onto concrete. We have laid waterproofing, tested it, and we have laid a protection layer of mortar on that about 25 mm thick, so that our protective work is done. Now, plumbing, let plumbing guy start laying water supply pipes. Plumbing guy starts laying water supply pipes and fixing of water disposal traps per details provided in approved working drawings. You have to check working drawings, you have to see them and accordingly follow, because there are many working drawings. Let plumbing guys start laying water supply pipes and fixing of water disposal traps per details provided in approved drawings, approved working drawings or shop drawings, and positioned on site to approved coordinated drawings, and test conducted according to specifications and approval obtained. Test means pressure test. I'm talking pressure test. First fix, you have to test every pipe laid and then approve it. Before that, you cannot proceed further activity. Then after this, reinforcements. I'm talking of reinforcement of raft. Reinforcements shall be laid for raft. That must be cut and bent according to Details provided on structural drawings without damaging laid pipes of water supply during placement of rebars or reinforcement. You have to take care. That care must be exercised for preventing depositioning of pipes either by fixing, I am saying depositioning or dislocation, you can say if you cannot understand depositioning. There was a position you left to fix those pipes, that position or location or level should not be affected, should not be, you can say, deflected, or you can say should not be impacted upon. It should remain in whatever profile you fixed it. Now, what is the care must be exercised for preventing the positioning of pipes either by fixing pipes post installation of reinforcement or before commencement is up to you. Means you need to take care of that. At same time, and say English word simultaneously, forms of raft means parallel activity, I mean to say formwork of raft periphery. I'm not talking of horizontal, I'm talking vertical. Form raft periphery vertically, and wall starter. Forms of raft periphery and wall starter. Wall at the surrounding wall, perimeter walls. Be carried out, and just imagine we are working on a raft which is not one level. One is deep end and one is shallow end. Shallow end may be 1.2 meter deep, deep end maybe 3 meters or more. And there is a better surface in between, sloped surface. We are working not same depth wall, or we are not working on same depth raft. We are working on different one, which is sketch I showed to you. So we have to keep that in mind. So let's say these forms are erected and the starters are worked upon, and also water stop. Water stop or water bar, as indicated or specified in engineer's details in structural drawings, should be installed in welding of connections in form of T, butting or overlapping as feasible, should be done per specifications and instructions, approval of resident engineer, structure obtained. What does it mean? I'm talking of this bar. This bar, maybe you know it. This bar means water bar. This is water bar, PVC bar. It can be different bar, but generally PVC bar is used. You might have seen this. This is a continuous one, continuous barrier for water to either go out from tank or to come from outside inside tank. Water should not leak at junction. It's both in vertical and horizontal. Wherever there is construction joint, we have to provide water bar in hydraulic structures or water retaining structures, because this is water retaining structures, shallow water. This is shelf. Shelf is a water containing structure. Water is there. Water can leak from construction joint. This construction joint can be vertical one, it can be horizontal one. When we are talking of horizontal one, we are talking of raft and the starter is there. And after that, wall shall be cast. So there is a construction joint horizontally, that is between vertical walls and horizontal horizontal surface, horizontal slab and vertical starter. This connection has to be given by water stopper. Half has to go during down one and half has to go during up one. Up and down means when we are doing concreting of raft with the starter, that portion is lower concrete. Or when we do upper one, wall separately, half of that bar should be done down within concrete, half left up, and that half left up should be taken up wall within wall, and that's horizontal joint, horizontal water bar. And when we are doing walls, we cannot do walls in one go. We leave walls, then that wall, and this wall means many construction joints could be there, depending upon size of tank. And that continuation of horizontal water bar fabricated one should go to vertical one without any joint in that. Continuous profile we have to fabricate or weld on site. And when we are talking of horizontal connection, we are talking, let us say, this is your profile of this should be one. There will be somewhere T means T-shaped connection of water bath, which requires to be welded. There can be somewhere different type one. It depends upon your shape of your profile of tank, and wherever is vertical, you have to join it vertical as well as horizontal in T-shape. And where there is crossing possible, though there's no crossing in their case, but there could be. So it has depend upon what sort of shelf plan you have and what sort of isometric of the shelf plan you have. You have to fabricate that water bar accordingly, and this you have to use common sense and do. Means half should be down, up half should be in concrete in one go, and second shift half should be. And if you cannot cast wall in one go in full height, just imagine. It's a very deep one. You say, I want to cast in two verticals, three vertical lips. You have to provide another water bar in that case. That's what all about. So I'll continue now. So what I'm talking about is, I explained to you, it says that simultaneously forms of raft periphery and wall starter be carried out, and water stop water bar is specified in ingenious details in structural drawings be installed and welding of connections in the form of T, butting or overlapping as feasible. Shall be done per specifications and instructions and the approval of regional engineer and structural engineer obtained. Structural engineer is also important here. Top marks of concrete level, top marks of finishing level, top marks of concrete levels shall be fixed to details as well as fixing of starter bars of walls be done. So I think you may be finding interest in this, and I can't say, it depends upon your intellectual. What actually you are looking for. Now let preparatory works for raft. Now we are going to preparatory works for raft. Preparatory works for raft concrete be inspected and approved by resident engineer for permission of pouring. Preparatory works. Do you know preparatory works? What does it mean? Maybe most of you knowing, but those who are not clear, I will just explain to you in short. We have temporary works, we have preparatory works, and we have permanent works. What do they mean? What is temporary work? Temporary work is which is done for supporting work, supporting preparatory works as well as permanent work. That is called temporary works. For example, ladder, for example, temporary stair, temporary scaffolding, and all such access to site, all such are temporary works. How to supply water, tank, mobilization items, all these are temporary works because these will be removed after activities are over. And what is preparatory work? Preparatory work means some work done on site to do permanent work. For example, in RCC, form work is preparatory work. Cutting, bending, and fixing still is preparatory work, though still is not a preparatory item, still is a permanent item, but that activity which is done to keep it in position is preparatory work. So preparatory work is we are preparing something to do permanent concrete, though still is also permanent, but we will take out form work. We cannot take out the steel. So form work and subsystem of form work, supports, and whatever scantlings are these, that is preparatory. We are preparing everything for producing concrete slab. That is preparatory work. Permanent work is whatever goes into project which cannot be taken out, which cannot be withdrawn. That is called permanent work. Concrete is permanent, reinforcing steel is permanent, Brick is permanent, blocks are permanent, plaster is permanent, decoration is permanent. All these for which payment shall be made to you on item-wise basis or lump sum basis, which cannot be withdrawn from site, which does not include preparatory work and which does not include temporary work, are called permanent works. So that's what we are saying. Now I was talking of preparatory works. So preparatory works for raft concrete be inspected and approved by resident engineer for permission of pouring. I'm not finding some income people coming in, no problem. I don't mind that. I'm doing my work. If people are sleeping, let them sleep. I least bother about that. If you are not interested to learn, it's your choice. My choice is to give something back to society. Let concreting operations, preferably from batching plant, be carried out using grade of concrete mix as specified, or generally be M30, SRC, OPC, as case may be. SRC, OPC, I'm saying in those days there was only SRC or OPC. Now there have been so many, so just this for information only. It can be GGBS, it can be FA. As case could be, and this be completed in one go. We are going to cast raft in one go. Raft with starter or kicker, you can call it. And surface finished rough. And joint for taking wall concrete be wire, brushed or scabbled later. Curing compound, if available and permitted, be spread or slab be cured by spreading saturated Hessian rolls per general specification of concrete duly covered with polythene membrane. This would be done. Operations of reinforcing steel placement. Okay, I'll have to finish the raft first. Now, concrete will be done. This raft concrete. We finished screen. To cover this waterproofing. We did our reinforcement bars, cutting, bending, and laying. Formworks along periphery, start or kicker formwork, and water bar. We did all this. We cleaned using compressor. We got approved. We fixed levels of top of concrete in both horizontal or slope surface along with battered surface of in between shallow and deep end. Then plan was to concrete after inspection. This ready mix concrete has to be ordered and poured, and we have to plan how to receive it, whatever concrete quantity is there, how much time shall it take, and thickness of raft maybe 25 centimeter or 20 centimeter, 30 centimeter, depending upon design, and that can be poured in one go in depth, and continuously if you can pour it, we can pour it, no problem at all. That is what to do. Slump should not be much, it should be moderate. We cover surface, finish surface of that, and finish it to some level that we are able to pour or to spray curing compound if it is high temperature area. It's not very low, then we have to protect, cure, concrete, cure hair crack formation as well as other cracks. If you immediately use curing compound, water-based curing compound, if we have, then we can use it for protection point of view, and then we can use a saturated Hessian on that surface after little it sets and covered with polythene membrane. That is called site curing in arid region, and that's what activity is about. And then we have to continue curing, and in parallel we can start preparatory works for wall, which preparatory works are rebar fixing and formwork, and that's what I am going to explain. For that, we have to see this kicker, which must be rough in the horizontal thickness of that we have to keep in mind, and clean all kicker area because water stop exists there, half up and half down, half inside already laid concrete and half is exposed one, which shall be worked upon during RCC wall, periphery wall work activity. Now, what I said last in this, concreting operations preferably from batching plant be carried out using grade of concrete mix as specified M30, etc., SRC or OPC or GGBS or PFA, SKS and be completed one go and surface finished rough and joints for taking wall concrete B. Wire brush and scabbard later and compound if required, if as available and is permissible. Spread for protection point of and later be cured by saturation poles per general specification of concrete covered with polythene sheet. Come on, next one. Operation of reinforcing steel placement in walls shall be started for engineers' details in design and completed works be inspected and approved stage by stage of progress as position of construction joints dictate quantity of work in one inspection. You may pour in two walls one time, alternate walls depending upon your sequence. There's no hard and fast rule for that. As you do, you have to use construction joints, water bars. Well, we continue. Construction joints shall be provided per details or as directed by resident engineer in consultation with structural engineers. Forms of walls shall be fixed per positions of joints. Make use of common sense to repeat one shutter from plate to complete construction of pool, shelf, and balance tank. During construction, you have to place in position water bar, water stop, sump pipe in balance tank, tank down pipes to ring main from overflow drain, blocks outs for underwater, floodlights, etc. All as detailed in engineer's details, engineer's drawings, and working drawings as approved by practically coordinating in a coordinated system or drawing from form. Concreting preparatory works which you have done or conducted are ready for engineers and resident engineers inspection and approval. Concreting shall be carried out according to general specifications and approved work. Main precaution to be undertaken is to avoid displacement of pipes during pour, for which one plumber must be available to do that job during concrete work. For roof forms of balance tank is also there. You know purpose of balance tank. Whenever there is a deficiency of water, replenishment is required, balance water is used, balance tank water is used, because there is a limit of cycles, limit of how many times you can reuse, discharge water from, dispose water from shelf through open drains, and at one time you cannot do more than, you cannot retreat it more than that, and then you have to remove that water from shelf and balance water, replenish that removed water place. Okay, so for roof form, there's a roof of balance tank. In shelf, there is no roof. For roof, there can be roof not of balance, not of shelf, but on top of that, if you want to shadow or cover the sky, shelf, that is different. I'm talking about balance tank roof, which is at level of shelf top. For roof forms of balance tank, care is to be exercised that form be conveniently struck after curing period is over. All right. So we'll come now next on This I am telling you some details so that you understand what I am talking about, because this is a risky work. Swimming pool, though it looks very small level, but excavation in various soils and various structures are required. Water leakage is possible, sinking is possible. All these points must be undertaken, because you will not get such details in books. In fact, yes, you will find some information through manufacturers of these tanks or applicant or those who are specialists in this, but that is very limited one. Well, having completed structural works duly cured, a water test is to be carried out. It's very important. Having completed structural works duly carried out, duly cured, a water test has to be carried out or conducted according to project specifications and international specifications. Probably it was long back, BS something. We'll discuss that one. As prescribed in specifications for water retaining structures, which may vary from 70 hours to 168 hours, retain water in full capacity conditions, and let let leakage be noted, observed by agent or and resident engineer along with structural engineer. Should some leakage be observed, mark spots inside and outside by color marker. Outside of tank shall pose no problem for marking, but for inside location measurements be taken, which be transferred after tank is dewatered or water is taken out. Now, leaking spots are ready for application of remedial works using epoxy mortar and injection as case be. It depends upon your adaptability, which one you opt for. Epoxy compounds must be approved prior to application by resident and structural engineer. Having remedied defects, let inspection let inspection be carried out by resident engineer and structural engineer. If they are happy, let further operation be carried out or start for second test by filling tank again till no leakage state condition is obtained. It's very essential to remember. It's very essential to remember by site engineer. Remember by site engineer and agent that water test is not cleared in time. In case that may jeopardize all following operations of swimming pool construction. Therefore, a great degree of care must be exercised by site engineer and agent during concreting operations. This one, water test of hydraulic structures or water retaining structures in RCC construction is very significant. I actually forgot this is in BS code. I'll tell you later. I have my method statement. It's from which code number is that? That mandates water test of all water retaining structures. We have to ensure that this is RCC. This is not 100%, you can say, impermeable. There are chances that water can pass through RCC structure. It should not, because it is RCC. People may say, oh, we are putting tiles inside and we are doing, no, that's not answer. That's not answer. Question is, tile has nothing to do with that. Concrete should not allow leakage of water. And that is purpose of this. Because we have U-shaped concrete here, we have base and walls, and we have construction joints as well. Where there's construction joint, there's water bar, no question of water to move from that. That's PVC bar, vertically as well as horizontally. That's not the problem. But your concrete is not very good, you can say. is a production element, manufacture the mixed one. No concrete mixes are uniformly property characterized. You cannot say whatever property one has, one by batch has, other one has same. There can be differences. There can be differences or heterogeneous work while application of vibrator is done for compaction of concrete. And that point is also kept in view. So what happens that we have to conduct 7 days test for this hydraulics because the depth is small. We fill it in layers. We cannot fill one go. We fill in layers that there's a codal requirement, codal mandate on this. We have to follow that one. We have to fill in something and watch, and then we have to say for so many days restitution periods. There's a complete method. I'll give you that detail later on. Because that is different. When I start that after this series, I have to start the method statements on project management, technical management, even site management. That's part of construction methods. When you finish this one, this series, I'll enter into that one because this is a long program, not short program. I want to give to public whatever I have got in my mind so that people may use it. Engineering, my purpose is improvement in quality of engineering. It's not my money. I'm not getting anything out of this. I'm just managing my all this time. So I want to give back to people in future. They may use it if they wish because I with my efforts got all this information myself for personal interest. So I want to share with you people, irrespective of you belong to this country or belong to that country. This is a full world society. So water test, people do not care for this, but that's very important. And when I say we fill the water, completely fill the water, we observe where leakage exists. That's very simple. We note leakage, then we point them, no, as I say, use color marking on that. Wherever that is done, this means those points are permeable. You cannot see concrete is porous there. It's porous, of course, but it is permeable too. Means there's a root inbuilt within concrete itself. The water is able to flow from inside of shelf to outside, and that is a dangerous one. So we know that one, and we can call construction chemical manufacturers representative because generally these materials would be used for rectification, for filling in these defects. So those people, if they false rock, it can be MBT or before on some master builder or whatever, or whosoever. I don't mind. Whosoever is the best one, SECO or whatsoever. These manufacturers, representatives, sales engineers, or others can advise better which is best one, efficient one. It can be injection, it can be surface treatment, or it can be whatever else. That method requires approved application and then retest is done. It's not simply that once you test, you repair and it is allowed for finishing. It's not that. If there's a failure, there's a leakage, it is investigated, as I said, by observation and then confer with manufacturer of chemicals and repair it and again test it. If second time it's okay, fine. If there's some more, repair it and test it. So it's a long one. You can say it's headache because if you delay, if you don't do work rightly, you delay your whole sequence of swimming pool. The shall delay, your milestone shall be adversely impacted, and you cannot deliver this part of job in time. So be careful for water retaining structures. It requires experience because autogeneous arrangement is there when you fill water. Autogeneous restitution, healing, etc. So many terms are there, which we will talk later on. So that you are clear about this, I'll move further. This was the purpose for swimming pool. I took it today. I could start later on, but I said no because it's rather you should know difficult item before you start other items. So I repeat again so that you remember what I spoke in this paragraph. Having completed the structural works duly cure, the water test is to be carried out according to specifications as prescribed in specifications for water retaining structures, which may vary from 72 hours to 160 hours to retain water in full capacity condition, and let leakage be noted, observed by agent and resident engineers and avoid structural engineers. Should some leakage be observed, mark spots inside or outside by color marker outside of tank shall pose no problem for marking, but inside location measurements is taken, which be transferred after tank is dewatered. Now, leakage spots are ready for application of remedial works using epoxy material, epoxy mortar, and injections as case be. A decision depends upon when you confer with manufacturer of chemicals. Epoxy compounds must be approved prior to application by a resident and structural engineer. Having remedied these defects, let the inspection be carried out by residents and the structural engineer. If they are happy, let further operations be carried out or start for second test by filling tank shelf till no leakage state condition is obtained. And it's very essential to be remembered by site engineer and agent that should water test is not carried out in time, that may jeopardize all following operations of swimming pool construction. Therefore, a great degree of care must be exercised by site engineer and agent during concreting operations. Then ask plumber or plumbing foreman to finish ring main system and get approval. Ring main, water supply main around this pool. Then commence waterproofing bitumen application on walls on external side surface according to specifications and obtain approval. And then simultaneously, in this parallel activity, carry out operations of wall styling, underlayers, mortar, spreading, which shall generally be thick layers. You have to fix on site actual levels of drain top of walls, etc. to enable tiler to understand where first tile from top is to be fixed. Top should never be cut tile line as architecturally looks awkward. This operation is very slow, precise and time consuming, but very important and requires constant supervision by a competent person that supervises. Having external waterproofing application been approved, proceed for protective system on bitumen in form of block or brick wall or some other treatment as specified or indicated in engineer's details, leaving holes for pipes installed, and then after few days backfilling can be started per specifications after clearing space and having been inspected by resident engineer. Remember that finishing operations are being carried out inside pool while pool services operations are carried out outside pool shelf. Installation of sand filter on already constructed plinth, construction of plinths for pumps, construction of acid chambers, construction of overhead water tank to be installed in filter room. Generally, OHT overhead tank shall be provided on steel frame. Trenches, construction for pipes electric cupboards, etc. shall be in progress. Sand filter plinth Sand filter plinths shall take load as designed, and design of plinth shall be requested in case not available. Concrete shall generally be filled in sand filter per specification of supplier of filter. Concrete means not set concrete, gravels, you may say, aggregates. Construction of pump house and plant room are of common nature as in usual buildings, so details are not included in this list. We'll talk later of common buildings. Piping operation shall take considerable time, so arrange it accordingly. Fix, fix prefabricated drains as supplied with holes. Prefabricated drains I'm talking. Perforated this may be. Prefabricated drains supplied with holes. There are holes in that. Without holes and without holes, and corner halves made of clay finished properly. Thickness of mortar joint should not be less than 12 mm or as specified. So there are drains, prefabricated one with holes, drains prefabricated one without holes, drains with corner halves. Means one corner means two triangular type drains, right angle triangle, made of clay, finished properly. Thickness of mortar should not be less than 12 mm or as indicated or specified. Having completed finishing operations, that is floor and wall tiling, fixing of surface drains, flooring in balance tank, and usual application of coat or two of acrylic bituminous emulsion paint inside walls of tank, piping work, installation of equipments and plants, fixing of floodlights, wiring and connections, grouting of spaces between surface of light and blackouts in concrete, in tank walls to be done with epoxy concrete, fixing external isolators and transformers. All accessories such as step ladders in tank wall, jumping stand, diving board, placement of PVC grills, resting on aluminum supports, bore on drains, projections as whole system be tested for successful run of pool. Again, I read this para. This is multi-item para. Be clear, no confusion. I said, having completed finishing operations, floor and wall tiles means inside floor and wall tiles, fixing of surface drains, flooring in balance tank, usual application of a coat or two of acrylic bituminous emulsion paint inside walls of tank. Walls of tank means balance tank, not shelf. Piping work, installation of equipments of pool and plants, fixing of floodlights in walls, wiring and connections, grouting of space between surface of lights and blockouts in concrete, in tank walls shall be done with epoxy concrete, to be done with epoxy concrete. fixing external isolators and transformers, all accessories such as step ladders in tank wall, jumping stand, diving board, placement of PVC grills, resting on aluminum supports. See, these are so many items. That's the reason I'm talking of this. So you will find all these items there. Bore on drains, projections as whole system be tested for a successful run of pool. Surroundings shall be compacted to receive synthetic drainable. Surroundings shall be compacted to receive synthetic drainable green carpet spread to specifications of manufacturer. There's a green carpet around this pool, which is synthetic one, drainable one. It's not simply water, drainable. It's perforated because it's a kind of perforated. External work shall be done. External works shall be done according to layout of swimming pool, which may include construction of compound walls with gates and certain pergola as well as some chain link fencing, all per contract documents. Swimming pool is ready for use. There will be changing room, there will be pump room, there will be completion of balance tank, completion of other items, poolside carpet, and all these you have to finish. Only then we can say yes. There will be many plants there. All right. Then specific points about tiling. Specific points about tiling. Sometimes engineer designs tiling work in different colors and according to lanes system in tanks to be used for sports purposes. In that case, tiling work should be carried out according to those architectural details, and that tiles ordering should have been done accordingly because you have to procure tiles in numbers. Pattern of tiling should not be disturbed in any case. Before taking off finishing operations, in a coordinated drawing of tank should be prepared, in which position of gratings, spacings of water sprinklers, positions of underwater floodlights, and all other details felt necessary be included based on module of available tile sizes and symmetry be maintained in all cases. Whatever cut tile required should be at bottom of pool, may be drain as fixed takes, two tiles on edge and same followed vertically and reflected in flow as well. Electric lights. Grouting of space behind the light shall be done with epoxy concrete only. Then it is in interest of agent to make ready coordinated drawings comprising all details of tile work. Sump pipes, underwater lights, positions of water inlet and exit system, positions of surface drains, and all other accessories in hand duly depicting foregoing dimensionally. This needs agent and site engineer to make available all informations in advance, that is size of tiles, size of drains, approved working drawings of related plumbing and drainage and electrical engineering disciplines. This detailed item needs concentration on part of site engineer, agent, resident engineer, consultants, and coordinated drawings, finalized in time so that everyone understands clearly what shall be done to achieve goal. Once, once things are explicit, operations as explained shall run very smoothly without any hindrance. Actually, this part of job needs agents' personal attention and contribution as site engineer may not find much time or be entrusted to a sub-agent if agent is also busy, but come what may, all be done to facilitate smooth functioning of swimming pool system as a whole to architectural and leisurely satisfactions. This was brief of an ordinary swimming pool, rectangular shape. I did not take curved shapes or design other designs. That is same thing, only form of shall be affected. Principles would remain same. Swimming pool was very important from my aspect, my thinking aspect, because it is a little complicated as well as structurally it requires your knowledge. There can be failures due to leakage in structure, all that, and the structural designs, of course, because designer also has to think in this. Whatever is on water side, stresses are different in concrete as well as in steel, and otherwise also all points must be considered because water can enter ultimately and can damage steel. So isn't that easy? Design remains very important, but prosecution of work, its implementation is much more, I can say important, much more significant than what way we think it's ordinary. Generally, it is ignored. I am watching here, I'm observing here, one work of soil or rainwater drainage system ongoing in this city. Swale, you can say a kind of outlet drain which takes water from various areas, rainwater or stormwater, and takes it somewhere else outside in the kind of drain, open drain or closed drain. I'm finding that in closed drain, bottom concrete vertical walls and top concrete, and they will connect it to somewhere. But they are not seeing any good structural work here. They are just doing normal concrete without even formation compaction, which is nonsense. This company, I will not name it, though it's a smart cities they call it, but work is not smart. Concrete is there, but they are not caring about concrete, and there is no water stopping them. So result would be that at one point of time, when drain is full, water shall pass through construction joints. Bottom one shall allow, because there's a weak plane, it will allow under force or the pressure of the pressure what to leak and go to soil outside. So it's not that professional work. Well, just for information purpose, the water retaining structure should be given due care. They're not taking it. I'm helpless for that. Now let's go to something else. I am going to talk about general activities in a building. Building. It's of course here I have listed this part in pages that is not many more, but sequence wise I've taken about 43 long paragraphs, then various measures we have to take, and then something like that. But what actually I'm going to talk about in buildings? I am going to talk about ordinary buildings RCC structure because I work generally on RCC cast in situ structures during my work time. I am not very well experienced on structural steel as well as pre-stressed concrete, but pre-stressed concrete is not very important for site work because that is done in yard with complete arrangement and under controls. So chances of quality in precast or pre-stressed concrete are remote. Means you may get quality in every way. It may be precast structure to be erected on site on cast in situ structure. Cast in situ is always a question mark because work is done on locations and controls are not very good always. So I am not interested about precast because first of all I'm not expert of that. Yet cast in situ is very big activity done all buildings. Buildings can be done these days with precast slabs and cast in situ columns, beams and bases and then cast in situ diaphragm on that. That's done. I'm talking of RCC frame building which got foundation or substructure and superstructure, slabs in sequence, walls, which may be columns and walls, columns, RCC columns, and the framing way, beams, columns, and continuation, and walls, which is block wall or brick wall, or if required, be RCC wall. That activity is very common. Activity is very common, but understanding is not common. Whatever we see on locations, we think that's what is done. That's what is engineering, but that is not engineering. In fact, that is just repetition of some wrong work. Every day we see buildings are being constructed in a conventional way, which is not a professional way. I'm going to share with you what I used to think and write in this time of 90s, and still it is valid because there nothing has changed, though it has deteriorated. Buildings are not giving that service they are supposed to give. So that was the only reason I wanted to share with public what should be done and what should not be done. It's very important from point of view of construction and engineering, what we think we have to do. This is, you can say, is that general activities in a building. Now, what we think we have for that? What I'm saying now, available what we have coordinates and grid plan for layout, arrangement, general survey details. This we have. What I said, coordinates, grid plan for layout or arrangement or general survey details. We have cellar floor layout or basement layout. Basement floor layout. We have ground floor layout. We have first floor layout. Layout when I am saying structural layout or architectural layout, both. Second floor layout, additional floor layouts, refer floor layouts, roof floor layouts. You may call it layout or plan, is same thing. When we are talking layout, means I'm talking of setting also. Roof layout, then details of architectural engineering constructions, details of structural engineering and bar bending, reinforcement, schedule, structural steel sections. And we have details of allied services, engineering and working drawings. These we have. We have to consider all these in a professional way. We cannot simply say we have it. We have these drawings. But most important part of this drawing is we cannot just say we have it and we to do it. When you are an engineer, when you are a professional, you are a coordinator, you have mind and you have to use that mind. Simply collecting a batch of drawings or package of drawings from professionals and keeping on side, oh, okay, we'll do it, that's not a way. Because these drawings are not done in 1 hour. Many hands change these drawings, and people generally ignore detailed coordination among various disciplines, which I discussed before also with you. What about coordination? So person who is on location or site, who is going to work out these details into physical forms, it's duty of that person to make sure that these drawings talk to each other. You got my point? These drawings, all drawings, architectural, structural, services, or otherwise, standard details must talk to each other successfully. Means these all should be in a coordination match. And for that understanding, you have to read all drawings. You have to study architectural drawing, structural drawing, services drawings together. Architectural drawings actually are required to be produced on site, and structural engineering is anatomy of that architecture. There can be discrepancy in both, and this discrepancy can impact upon services drawings. We have to keep this in our mind from foundation on the top and then finishes. We have to ensure dimensions of architectural drawing in both grids, x-axis, y-axis, A or 1, then A1, A2 or whatever it is. We have to ensure that structural drawings also remain same, because generally dimensions are missing or least given on structural drawings. For everything, we have to make sure that these drawings are together. There's no discrepancy. If you discover discrepancy is there in vertical details, in horizontal details, or in sectional details, you have to see all. It takes some time, of course, when you start, but if you discover there's a mistake and error, that can be rectified by clarification. And you have to issue those letters of clarification request to that person, the designer or representative of designer. That must be corrected before it is done on site. And that's called technical coordination. It can be done for all drawings. You have to do it architectural, structural drawings. You have to do architectural drawing itself sometimes, and the structural drawing itself. You have to do in alliance to services, electrical services, mechanical HVAC services, gas services, building management services, CCTV services, SCADA services, and many, many more. Whatever is there involved in, you have to see that. You have to be clear that all drawings are speaking to each other. You're not able to find any discrepancy on them, so that this can be put to work on site. That is more important than rushing of, oh, I take a structural drawing, as usually people do it generally. I give me the structural drawing and go try to start this one. Because you cannot take architectural drawing and do work if the structure is not there. You cannot, if excavation is not done, you cannot excavate. If you don't have structural details, you cannot excavate. You cannot excavate based just on architectural details. This point was understood very well. So my purpose, my objective telling you is be patient. Do not keep drawings in cold store. Oh, that day when that person comes, I'll open this. Write what you observe in this. Find drawing numbers and page or section which is asking a question. Coordinate with the structural details and other details. There may be elevational problems. There may be plan problems. There may be clashes in columns locations. There may be clashes anywhere on landing details. There may be clashes in beam sizes. There may be clashes everywhere. There may be clashes in foundation and specifications times. So many points are required there, which is all part of field engineering. There may be definition of bearing capacity sometimes, and so I have seen that. इसमें और bearing capacity this much. Then you have to ensure bearing capacity. You have to test after excavation is done, the bearing capacity is this, which means if bearing capacity is not reached, means there's a question mark. You have to raise that, clarify this. This all is done. So I'll now continue with explaining to you. Welcome all those who are coming. Ushodayam. Welcome. Okay, right. Now I say details of various services. Okay. Set out building per coordinates. Coordinates you have, as I told you, these can be relative coordinates or these can be actual coordinates. If these are actual coordinates in line to GPS, you can use services of GPS experts who can establish coordinates on site, benchmark maybe level coordinates as well as route coordinates as x-axis, y-axis in line to GPS, or this imaginary coordinate given to you by someone. Mean to say you have site layout with you on paper and throw that on ground. Set out building per coordinates, grid plan and obtain approval. Go ahead with excavations with due respect using record drawings, if any, till final levels are reached. I'll discuss record drawing again. For footing or for pile caps, do complete piling works according to pile layout drawings. Pile layout drawings and let piles be approved after test and finish piling operations per detailed codes and project specifications, as well as found all pile caps. In case piling is not needed, prepare excavated surface of footings for formation levels and compaction of complete area of footings is done. Strip or plinth beams and get resident engineer's approval and blind compacted surface to level as defined in drawings. Top of blinding surface reference. I give some sketches SK1 and SK11 here. I'll show you later on because these are sketches. There's no problem, you can show it. Let me now explain to you what I'm talking about record drawings. I talked before also, but this other video, maybe you may not find this one. What is a record drawing? We know it. Maybe many of us know. I refer that while you're excavating, you have refer to record drawing. Services record drawing actually. Services running around or below your plot which you are going to excavate. It's not isolated site, it's a site within some city or some other area where services are available, live services. You have to ensure that you do not damage those services. So how shall you know that? You're not a magician. Your eyes don't have x-rays that you can penetrate soil and see. This means you need some support. Support of those authorities or bodies that are responsible to keep records of these services. Maybe it's municipality, maybe some other development department that you have to know. You have to access to them and get these drawings. This may water existing drawing, existing water line, existing sewer line, cable, or some other. You cannot excavate blindly. I'll excavate and see later. I excavate first line, let me break water line and cable and I do later. That is not permissible. It's not permissible per law. Well, I'm not talking of my beautiful country, I'm talking of in general. There are services coming from plants, from facilities, or some other. There may be services there. You must know if there's a system in your area. You can get this information from those areas, as I explained, from bodies, and ensure there is some service or no service. If you find there's some service, then you cannot excavate that way. You have to use manual excavation until that service is discovered, and then you have to decide whether or not that service be diverted. If that is to be diverted, you have to see that. That's an important question. If it's not diverted, you can blindly start your site for purpose of covering a setting time, saving time in mobilization. So these record drawings would help you where you have to do excavation manually, and then after discovering service you have to decide whether or not to divert that service or to protect that service per specifications or instructions given to you by that authority or that body who maintains these records. That is one point. Then after excavation you have to prepare for dressing, compaction, testing. As I said, it's not simply saying that we have excavated and I've seen there. Nobody cares for this, After excavation, you have to dress it, you have to compact it. And once you have to compact it that you are satisfied, you have to conduct density test of soil. It's called field compaction test, field dry density. That field dry density, you have to approve it, get it done. You have to approve bearing capacity also, if required. You have reached this section, you have to see what bearing capacity the soil has. There will be condition on your design that you should have 20-ton capacity or 10-ton bearing capacity on site. And if you cannot achieve that, there should be someone else design this. With some assumption, design was done. This bearing capacity we assume. Maybe they tested that time, it was there, but they took some measures and changed that one. Okay, you must get this way. If you don't get, don't do that. So you have to make sure that you test it, bringing a truck, applying a small plate and test K factor of that. So there is no bearing capacity. So you know bearing capacity and you know compaction, dry density. Both you can decide further action on that. And if you need more, more tests, do more tests, no problem. Of course it costs, but when quality work is required, so you have to spend cost. Okay. Now I say sketch 1 and 11. Let me see just a minute. I'll see if I can show you the sketch 1 and 11. At 11, I'm having a problem. I see sketch 1. Let me see it. Better to see it now, otherwise you'll forget. Sketch 1 to 11. Yes, I see. Okay, lucky that not. Little bit page, actually. Sketch 1 to 11. I'll show you all the sketch one time, but it's difficult to find the ideas. I'll show you later. I'm sorry. I could discuss immediately. Yes. Transfer of access. Transfer of access to foundations or footings and beams, raft, pile caps, or as case be, and finish foundations operations such as spreading polythene visqueen 1000 gauge, or it can be whatever gauge, I just written it, reinforcement placements for footings, raft, piles, beams, etc., and erect usual forms and fix marks for concrete pour and pour concrete for specifications and the starter bars for columns let go in for hook. Just one statement here it is for foundations, because we'll discuss this activity separately from form work from still other. Just mode I've given: transfer of axis of foundations, x-axis and y-axis, or both coordinates, footings or foundations, beams, raft, pile, caps, as case could be, finish foundations operations such as spreading polythene sheet or whatever gauge, reinforcement placement with spacers for footings, rafts, pile beams, and erect usual forms around and fix marks for concrete pour, means top level of footing, and then pour concrete after approval per specifications, and starter bars for the columns let go in pour, means your starter bar, I mean to say first vertical bar that goes into foundation is called the starter bar, and that has to go in concrete. So you pour raft or full the foundation starter bar is, and you know it very well. After then, waterproofing treatment application and approval. Waterproofing, actually we call it waterproofing. Again I say it is soil protection. Protection of concrete surface from adverse impact of soil, because it shall be embedded, shall be backfilled, and there can be chemical soil, sulfates, chlorides, all those which can cause impact on concrete. So this isolation layer of so-called waterproofing treatment acts as a barrier of that adverse impact on concrete, and this waterproofing itself is protected by another external layer, so-called block layer, or some other layer, example thin ply or whatever else. This depends upon the design. And as mentioned in this footing work, in case it's not applied, polythene is not applied, then bitumen can be applied and protected by 1:3 protection on that before fixing forms and reinforcement. So this depends upon the details that you have. I'm just telling my experience. After that, surface of concrete where next concrete has to be placed shall be wire pressed so that complete latence is removed. Scabbling done otherwise after concrete gets hard, which is not preferred by engineers. Now what I say, what is it mean is very simple actually. You're doing your casting, your foundation portion where reinforcement is vertical, that portion has to be roughened. Other surface, exposed surface, you have finished according to grade of finish. It's not cement finished, it's normal float finish, timber float finished. Portion in which column bars are used, that portion cannot be finished. Remove that loose if you can at time of finishing. If you are not able to remove that, you have to leave it, then you have to hack it later on. Use your equipment of hack, and you have to expose all those so that aggregates are seen. That's what I'm talking about, and this is for everything. We'll go further in this. Then say that I said surface of concrete where next concrete has to be placed shall be wire pressed so that complete latence is removed, and scabbling done or hacking done after concrete has set in, which is of course time consuming and hard work. Let us strike forms. Next day or 24 to 48 hours according to general standards. Forms are struck. After time of 28 to 48 hours lapsed, and curing continued. Generally, curing happens in hot weather conditions. People here I've seen, they're not understanding what to do. Again, I'm telling this curing application, though it's not part of that one. We have to cover immediately foundations if permissible by curing compound. It's not bad. Water-based curing compound can be used there. And if you want to use wax-based, can also be used, no problem. You have to cover surface of concrete immediately after shuttering is removed. You can say vertical surfaces of footings and horizontal surfaces. All have to be covered with curing compound. And vertical surfaces not certainly compel direct application of curing compound. First you have to spray water on that and then apply curing compound on that. And horizontal you have already applied while you are doing concrete. And then you can cover that by saturated Hessian covered with polythene sheet and let it keep kept wet there for a number of days, and you have to start working above. So forms are removed and curing is done. Carry out operations in form, erection in starter and pour, which shall act as a base for superstructure, and columns, stub columns. Means if you cannot cast your kicker or starter concrete at time of footing concrete, then you have to first finish that starter bar. Though it's not very essential, but the general practice is that you position your kicker or starter concrete area and pour it so that your foundation base for column, your base for column is clear. You need not worry about that. This is general, but it's not essential. You can do it without that also. Well, it's up to you. No problem, no dispute on this. It's a question of just another day. Then I said carry out operations in form, erection of starter and pour, which select as base for superstructure, and columns, stub columns you can say. We call portion of column within soil. Low ground is stub column, and then the stub's name is field name. You can call starter column, you can call stub column. Now, after curing of concrete has been over, apply dry surface of concrete to remain in contact of soil of backfill with waterproofing acrylic paint and bituminous treatment on that as specified in details. All footings, stubs, beam sides, etc. shall be treated and side of stub walls in foundations over beams. So this application of cold applied, it depends upon which one you are using. This waterproofing compound or soil protection compound, bituminous paint. You can do that. It has to cover completely horizontal and vertical surfaces of concrete. After that, you have applied surface of concrete with paint, waterproofing membrane, and you have to protect that. Apply bricks or block wall protection for treatment applied or with some other alternative protection material as agreed with resident engineer or given in details. Later on, after that, for forms of footings, wall which is supposed to protect treatment could be used as a form for footings, subject to approval of resident engineer and time shall be made. Yes, this is a different one I'm talking, though it's not very good. These people do like that, which is not actually acceptable. What they do, rather than using timber forms or plywood for forms of footing sides, what they do, they put block work or brickwork in that place and pour concrete in that. after application of waterproofing system. This is actually not recommended that you are doing reverse activity. You are constructing in place of foundation form, block work, and doing waterproofing or soil protection layer inside, and then you are concreting. People are doing that. That's why I've written here, but that is not good one. First do concrete and then apply protection layer and walling for protection of block. That's what should be done right way. Because you are not sure vibrator has you applied correctly, concrete has gone everywhere, there's no honeycombing on concrete. You cannot test everything. So do right job rather than being over smart or being shortcut. I have written here because it is done. Just the measure to tell this can also be done. People do that, and sometimes even some consultant accept this. So I can't help it. All right. So I then the forms of footing, wall which is supposed to protect this treatment could be used as a form for footing subject to approval. So I explained to you, it is because of save time. Time saving is important, or quality is important, durability is important. You have to decide being a professional one. After protection is done, after protection is done, backfill shall be carried out, for which approval of original engineer shall be taken for space being cleared and to make sure simultaneously that underground works of plumbing and drainage as well as other parts of allied services completed, duly tested and approved. Yes, backfill. Generally ignore item. People do not give importance that this deserves. Backfill around foundations is very big item. Particularly, you have to ensure that it's not just fill up, it's backup. No, it is densification. It is pure soil that you are going to use. Whatever fill material you have approved, it should really fill material. It's very important one. You have to see that all rubbish, all unrequired materials are taken off from that area, that space. Complete clearance must be there. And this material which you are going to backfill must be approved one. It should be graded fill. If you fill clay, you waste your building, you waste your time. There are only two ways. You just arrange for and approve, have approval of. That's called graded material, graded mix, or however you manage it on site by mixing various proportions. That's one way. Or other one is sand filling. Doing sand filling or sand filling. Only problem in backfill is that it cannot be done in layers more than 20 centimeter one time. That is a problem for every engineer and every contractor because it takes time. If there is 1 meter depth, this means you need 5 layers. If you have 2 meters depth, then you need 10 layers, and every layer must be filled in sequence, watered, compacted, and density tested. This means you have to do same exercise for number of layers, and every layer must be tested. So of course it takes time. Indeed, you cannot avoid that. You cannot just take shovel, put concrete from stack of concrete, put soil, fill soil, imported soil of the soil, and pour into that, just like people usually do. People do not understand what is compaction. People do not understand what is densification of material of soil. They do not understand what is consolidation and how shall to achieve this. Reason is that people fill soil just for purpose of filling and forget everything, and they do floor on that. This can cause future problems. Therefore, best approach is you have to do in layers according to standards. Fill 30, bring to 20 by compaction. Compaction is very important. Compaction is not permanent, it is intermediary. It is between existing soil, undisturbed soil from formation level. That soil is undisturbed. Disturbed soil is only that which has been excavated. But which has not been excavated is still natural, that is undisturbed soil. Undisturbed soil and a layer, all layers of backfill, you have to impart property of undisturbed soils to these backfill layers. And that can come only by first densification or called compaction, and then it passes of times of years and decades to come, maybe 50 years, 100 years. This can convert to state of consolidation. You densified by compaction and automatically by passage of time it will be consolidated. Consolidated means you can say a kind of undisturbed soil. That is purpose of backfill. It's not joke. It's not just to fill in. There's a sense behind that. There's a criteria behind that. You have a goal to achieve consolidation in solid soil. Solid soil of given density, given consolidation, given strength, given bearing capacity. That's why it's very important you do not take it easily. Compaction of building soil, there is 98% requirement of dry density, proctor dry density in each layer. If this is below building, around foundations, if there's no building, general fill or other fill. What I'm talking about is structural fill. Structural fill means fill that can act as a structure also. You are filling soil 98% proctor density, though it can be more, but that is minimum requirement. It can be 100%, it can be more. That's what you have to achieve. And also, where there is no such a structural compaction, structural fill, general fill is these, that can be 95% also acceptable. For example, there is no much load on those areas can be 95%, or in very open areas can be 90%. It depends upon what sort of area. But when a structural area is there, structural loading is there, everything is there, you can achieve 98%. Without that, you cannot continue. It's not acceptable. So this is very big activity. Do not take it easily. It's not simply say take 7 days for this. No, you have to see how many layers are there, what material you are going to use. That is very important point. Though it's not in the book, but I just explained to you for purpose of the warning that it's a part of quality system, technical system. People don't care for this. This actually was a question to me, and there's some problem in backfill on a project. And what he told to or consultant, okay, you have done 40 centimeter. Our foreman did 40. Foolish foreman, what to do? He did in the Harja of 40 centimeter. Okay, this is no problem. You have done 40. We accept this, but do one thing. What? Get Traxler machine to site. Do you know what I'm talking about? Traxler machine. There's a machine on railway lines which moves on that and compacts soil below railway track. With that machine, that's a Traxler machine. Track below track compaction. So can you get traction machine? Is it possible to that machine? So that was just a taunting statement made by that consultant to me. So we had to take out that soil, in fact. We had to take out that soil from that fillet room and do it again. Well, you should know it before making mistakes. Mistakes only can teach you, no professors. So I was talking about, yes, because here, after protection is done, backfill shall be carried out, for which approval of resident engineer shall be taken for space being cleared and to make sure simultaneously that underground works of plumbing and drainage as well as other parts of allied services completed during tested and approved. Allied services may be there, sewage pipe, water pipe, or some other pipe. You have to take care of that and do all. Then should space exist between finished slab level and top of plinth beam to be filled with block or brick wall duly waterproofed and protected. So you have to do that care. You have to take the care of space between finished slab level and top of plinth beam if there is. Backfill be carried out for ground slab, first slab and compacted if required. Now let's go further. Preparatory works for columns between ground floor, first floor should simultaneously be in progress when ground floor slab operation is going. Ground floor indicates ground floor. GF, this indicates ground floor. So why it says even ground floor work you are doing, you can take columns work. It's no problem there if you can. Ground work is going on. We call it actually graded floor. Grade floor means a floor that is located at ground floor. This is not connected to framework, but this is for purpose of floor only, ground floor. So that work is not very big work actually. There's no side, there's no reinforcement. I'm sorry, there's no form work, simple reinforcement, or you can say BRC there. Maybe you can say grills, or you can say mesh structure, steel mesh. And already block work is there around, so it's very simple one. But that is called graded slab. That is done, and at the same time, you say columns can be taken up. That's what here is given. And it is technically, you can say activity based. If you can do that, no problem. And I said preparatory works for columns between ground floor, first floor should simultaneously be in progress when work of graded slab operation is ongoing. And then finish ground floor compaction, because we are working ground floor, finish ground floor compaction and all related concealed pipes and conduits for all services found necessary according to details duly approved, and get ready for blinding operation. Blind surface to required level to specified thickness and smoothen surface to be standard. This work of ground slab, after fill up is done, backfill is done, you have reached up to bottom of slab, blinding, you can say formation level of grade slab. After filling all and after completing all plinth beams or other beams, all area is required to be graded to do concrete of grade slab. For that you have to prepare to compact all fills as usual, to provide your supporting concrete or blinding concrete you can say, and then you have to work for ground floor structural work. That activity is going, and that's what happens. After then, apply isolation membrane in form of polythene sheet on blind surface, and arrange for reinforcement in form of prefabricated mesh of approved make. Then erect Edge forms on perimeter and install steel mesh approximately in middle of slab. Install compressed filler, flexile all around of profile or plane to form a movement joint. Filler means you have to provide a gap between plinth beams and ground slab, because ground slab is not a structural item, it's just a flooring item resting on backfill. So a compressed filler named Flaxel, someone else, Flaxel is known, some trade name, I'm not saying that, that should be in between plinth wall and grade slab so that it is free to float. After that, you have to instruct electrical man, instruct electrician like a foreman, and let him do his work. Let him finish conduits laying and conduits laying in grade slab, and it should be approved by electrical engineer, this electrical inspector. After that, plumbing man, and also same activity, he has to provide sanitary blockouts required for WC, for shower, or for whatever purpose. Sanitary blockouts a must. You may know blockout is blockout. Blockout means there may be many blockouts, means a portion where you will not do any concrete in grade slab, that you have to leave it because you have to fix your units there later on, and once you install units then you can fill up that. So those blockouts, block PLOCK blockouts means no place avoid in concrete. So electrical man shall provide conduits, and your plumbing man would ask you to leave this, and then it's called a kind of coordination. Wherever your drains are coming, your soil pipes are inlet coming, and all that. This is a point of coordination. You have to do it. Then, yes, blockouts are there for telephone also. Although now these days there's no telephone business. In those days there were telephone lines, so we used to do that also. That's the, if you want to provide that exchange, you want to provide, or you have to take landlines or some other thing that you will do. But this is not very, you can say, common these days. So make complete arrangements in final stage for works to go. Check all movement joints and see that compressed filler is in position and polythene sheet, polythene membrane goes through in between filler and blocks or concrete surface, and good grip exists. Then inspection be conducted, for which request must be raised and sent to resident engineer in advance time as specified, in approval for concrete pour obtained. Pour this concrete of slab, graded slab, as indicated, are required and arrange for curing by either using curing compound, spray, or flooding surface with water. Next day, on already spread saturated Hessian. Same day, after concrete starts setting, for protection of cracks, particularly in dry, hot weather condition. And that Hessian can be covered and should be covered by polythene sheet so that water is retained within and doesn't evaporate. Now complete all columns up to beam soffit level, but better during concrete pouring if a few centimeters will left. Now I'm talking about superstructural columns. I'm just straight away giving this. What activities I'm not mentioning in this because there's a separate one. Complete all columns, superstructural columns up to beam soffit level. Beam means first floor beam. Beam soffit I am talking. Soffit means horizontal surface of beam. There's a down stand, and down stand bottom horizontal surface is called soffit. Complete all columns up to beam soffit level by better during concrete pouring. If a few centimeters be left, as masons shall definitely fill concrete above mark and forget to remove that. Well, this is practical problem on site. Means you cannot exactly take exactly level when you fill concrete due to masons are too fast to work, and when you are pouring concrete, people don't exactly measure where you are. So either chip later on or keep 1 or 2 centimeter, 3 centimeter below top level of column, that soffit level of column. That's practical. You have to decide yourself. At time of fixing beam soffit, the same shall be chipped out, consuming manpower to be wasted or applied for no gains. I'll show you this in a sketch, because if I'm not able to find immediately number of sketch, there are so many sketches in this. I'll show you that one. Make sure that all dowels, dowel, Dowel. Let me explain to you that one, dowel, before going further. You are going to cast columns up to beam soffit level. There can be there can be reinforcement other than column reinforcement. There may be some intermediate beam at you can say window level or at door level. There could be. Nothing can be guaranteed here. Then could be some fascia, some decoration structure. All those shall have horizontal bars. All those which are connected, which are interlinked to column. And also there will be more bars above. If you are taking only up to first floor level, you may have connections to beam horizontal bars, and those horizontal bars may be in L shape going down into columns so that moment of beam can be transferred to column. Beam may be 40 centimeter, 30 centimeter deep, and that bar may be 1 meter deep in length at L. So this has to go into concrete as embedded one or inserted one. So for that, you have to take care. Means you have to provide horizontal cut bars as dowels. For that intermediary beam, if there is someone, or fascia beam there is someone, you have to provide that dowels. And that is actually very complicated task. If you are shuttering there, you have to drill shutters and put that portion inside so that overlap is also made. Or you have to cast only up to that level where dowels are not in. But generally, dowels are provided. Dowels means a steel reinforcing bar which would be connected to real bar using overlap, because there is maybe 6 meter length of dowel. You cannot do. You have to provide only practical one. Let us say you provide 50 centimeter, 1 meter in horizontally. So that must give you enough length for overlap of other bar, which is continuation. That is what dowel is about. I have seen some people doing idiotic work on site just before going for that. I explain to you why. What they do, sometimes dowel is 12 mm or something means that way. What they do, they put that one and bend it inside. This is not allowed. Foreman tendency is always different. To stupidify work, this foreman do. All foremen. Our foremen, other nationality foremen, mind is same. They want to cheat their people only. Do not do that. Do follow drawings and engineering. We'll go further. I think more on Engineer Chetan and Mohammed. Welcome both. Okay. So, yes, what I said, dowels. Make sure that all dowels All levels for lintels or beams for transfer of bending moments from beam to columns top at top are all in position before concreting column till top level. Arrange for curing either by curing compound or by wrapping. Saturated Hessian protected by polythene membrane to retain water as much as possible from being evaporated and keeping continuous cool, and top also wrapped or by pouring water all time on that. This is procedure of curing. I'm just advising here. Means once you remove foam after casting of concrete, do not leave as it is. If you are using curing compound, you can apply that, or if you are not using curing compound, you have to wrap it in saturated Hessian covered with polythene membrane and allowing water as required. You use less water if polythene membrane is on that, so that evaporation is protected. Evaporation not allowed, and also continuous cooling is important because you have to ensure required temperature of this concrete for purpose of its chemical reaction. You cannot allow that temperature to exceed. Maybe we are not clear about this here, but temperature of concrete, it is a wet concrete or it is set concrete, it's a hard concrete, is very important to maintain. Otherwise, if there is a change in temperature, means there is a change in thermal energy transfer, thermal energy movement within the structural of concrete, is atomic structure of aggregate as well as soil. This can cause restructuring of concrete material, and which impacts upon durability of concrete. So it is advanced technology, but curing is very important. Maintenance temperature is very important at time of pouring of green concrete as well as at time of its reaction. That is very important. That's purpose of curing. It's not simply that we are curing. Curing means there is some disease. We are protecting this material from that disease. That's purpose of curing. Not simply saying there's a reaction and water evaporates. Why water evaporates? Why can it be protected? What is purpose behind? That must be known to us if we want to understand concrete technology. Otherwise, we are no different than a layman, a foreman. When curing compound is used, first saturate surface of column well and then apply compound as instructed by manufacturer for the retention of water on column surface. Curing compound has been found effective where scarcity of construction water exists, but application should be done carefully to make sure that perfect compound film forms on wet surface of column concrete and top be saturated with Hessian. What I'm saying is vertical surface where you can apply curing compound, you cannot directly apply this. First you have to saturate it with water, because curing compound purpose is to protect water from being evaporated. It's not that curing compound cures it, it protects it. So you have two types of curing compounds. It can be water-based or it can be wax-based. Generally, water-based is used, but wax-based can also be used. Only one problem is wax-based. It covers the surface 100%, and it's not possible to get degraded in 6 months or less than that. In that case, you have to apply another deboning compound to get it off, or you have to chisel it yourself. Otherwise, we are using water-based curing compound, and this water-based curing compounds protects evaporation of that water you sprayed on, and that water you sprayed on doesn't allow evaporation, so curing is completed. And top portion of column section, which is the dimension of column section, that can be covered by Hessian and polythene. This way, curing can be continued. This is detailed explanation of that. In that case, that's who When compound is used, when curing compound is used, a second coat of degradation, just I explained to you, when curing compound is used, a second coat of degradation compound shall be applied if plaster or other finishes are to be carried out and bonded on the surface during period in which film shall remain in existence or in life depending on manufacturer's catalog or data sheet, and generally it may be 6 months of day of application of curing compound. So I explained to you already. Now go ahead with the operation of form erection of beam soffit, because we just talk only for column surface, column vertical surface. Now beams, you can say drop beams we generally call them, or you can say down stands, it's up to you. Drop beam means drop beams from slab, or down stands from slab, from beam portion. Go to work that, go ahead with operation of form erection of beam soffit sides and suspended slab soffit. So there is beam soffit, there is beam sides and suspended slabs soffit, or any other element which is a part of preparatory work, means we have to start form work and below form work supporting system. This is very common, people know it, how to do it, but we have to know it in a professional way. We have to ensure depth of beam, how much is this, maybe 60 centimeters, maybe 30 centimeters, and out of that how much is down stand, maybe 20 centimeters, maybe 40 centimeters, maybe 50 centimeters, maybe 1 meter, depending upon. So we have to ensure hydraulic pressure on sides and soffit of beams, which shall dictate thickness of plywood as well as use of bolts or tie bolts, you can say, that's required. All this we have to decide. Let fabrication of beam stirrups, fabrication of beam stirrups or rings, you can say steel rings, other details, bars, etc. go on in yard of steel foreman. So you have given all these details in past to yard, fabrication yard of your reinforcement, means this is going as parallel activity there. Fix level marks on columns to enable foreman fix beam soffit, means you are working on form work here other way. So you have to provide level marks on columns, means datum lines on columns, already done columns. It can be any line, it can be 1 meter from floor level, can be 2 meters from floor level. This is for reference from which line they can take mark of beam soffit. You can put some line on all columns by level or by level, say water level, or by, you can say, staff level, as you wish, and get ready so that beam soffits can be located. So fix level marks on columns to enable foreman fix beam soffit levels and whole slab levels using inverted level method or other method of reduced levels if possible. Typical forms of suspended slabs. Sketch I'll give you, I'll show you. After that, make sure that proper releasing agent has been applied on shutters. Forms. Releasing agent means oil, shuttering oil. We call it releasing agent in professional language. Cannot simply call it oil. Make sure that proper release agent has been applied on forms before going ahead with raising of fabricated reinforcement to slab shutters. Release agent should be of quality as approved and be dried before fixing or placing reinforcement at that location. When placement of steel bars is over, means we have undergone placement of steel. When placement of steel bars is over, electrical man or foreman, plumbing one, mechanical man, etc. all for installation of allied services as needed at this stage. Allied services means electromechanical plumbing services or other building management service, or wherever you can say inserts are required to go into this suspended slab must be there to work, because all these are inserts in fact. Fixing of conduits and boxes, block outs for sanitary and engineering to be in position as detailed in relevant approved service drawings. All. Then, before fixing sides of beams, you have to remember that. Before fixing sides of beams and soffits, axis lines of slab should be located up. And from that axis line of slab in both directions, positions of all beams to be checked for its true measurements. From that central line or axis line, main axis lines, location of beam center line is ensured for correctness. Close sides of beams and to lines and fix concrete spacers to correct positions and of specified thickness and bring reinforcement work to pourable standard. Inspect yourself throughout thoroughly and see if something is missing or undone. Keep some hole in beam shutters for final cleaning and close it before commencement of concreting pouring operation. And also, important point is level of slab soffit. I have seen generally on many buildings unevenness in soffit of suspended slabs, as well as unevenness in levels of beam soffit. It means people do not pay regard to implementation of levels and surface looks uneven. They may say we can cover it in plastering, which I condemn, because your activities are not to cover previous activities. Activities are activities. Purpose of plaster is not, purpose of rendering is not to cover defects. Purpose of plastering and paint is to protect previous surface, previous membrane, previous layer. So you cannot say that we will do like that. Level is level. You have to ensure whatever level are required must be maintained throughout work, preparatory work. Soffit level of beams or soffit level of slabs and levels up to which concrete is required to be poured and finished must be professionally done. You have to ensure levels are done accordingly. Don't depend upon irremediable measures that we will do this and we will do that. Then there's no difference between a foreman and an engineer. Having satisfied all elements and disciplines, normally call a person resident engineer on request of already dispatched sheets of concrete pour. Why I'm saying already dispatched sheets of concrete pour? Because you have to provide conventionally 48 hours notice to that person who is authorized to approve your work, and this means your report must have gone with complete details. But be sure when you send details for approval, this should be done before that person comes, and you must be sure of that. Otherwise, don't send details. So call resident engineer on request of already dispatched sheet of concrete pour, electrical, plumbing and drainage and engineering for inspection to obtain pour permission reinforcement. When we sell in concrete case, when you are going to pour like slab, suspended slab, which is multi-discipline preparatory work, simply call we are pouring a slab. What slab you are pouring, you don't know. You are not only pouring slab and beams, you are going to cover, you are going to conceal in this, embed in this, insert in this, electrical items, blockouts of air conditioning, plumbing items, and many more items. So it is multidisciplinary activity, and therefore it, it imports multidisciplinary supervision, multidisciplinary inspection, and that is very important. It's kind of a permanent, complicated, multidisciplinary work. Therefore, all would come, plumbing inspector would come or engineer would come to inspect plumbing blockouts or inserts. HVAC guy would come, or if there's some equipment there, that guy would come. Similarly, reinforcement, structural engineer will check, level civil check, everything will be checked in. Both you and they would check, and all shall individually approve their disciplines. Means there are 4 or 5 disciplines which will be submitted for approval, and they will grant sanctions or sanctions with comments, whatever, depending upon your slab. So that is what this inspection is very complicated one, tedious one. Everybody would come and sign that paper of request of inspection along with permission to pour concrete, and you have to submit concrete pour plan also as a part of method statement. You may say, how shall we do it, what frequency would be there for concrete trucks to come, all that, how many hours should it take, what is provision of standby vibrators, what is provision of standby equipment to mix in case certain emergency comes in, and how shall ready mix arrange all this, what shall be grade of concrete, what shall be value of slump, all this, and what sort of cement you are going to use, approved one or some other one, or if it's GGBS or it's PFE or it's microsilica one, all this shall be required to constitute part of your submission, which is called professional submission. After this, having satisfied yourself of all elements and disciplines, normally also I have already done this, and engage steel fixer. People justly call bar bender here. Well, it doesn't matter. Engage steel fixer on slab forms and carpenters to look after dispositioning or delocation of spacers, concrete spacers, and binding wire and loosening props respectively during concreting on prepared and approved works. Danger lies on slab work always. Even if you use proprietary system, whatever system you use, danger always lies there. Generally, we call when you use this proprietary system of 1.2 meter and 2.4 meter, this is structural system or couplock system. It doesn't cause a danger. Yes, that's right. Or if you parry girder, you say even then, nothing is sure, everything is possible. For that purpose, we have to keep our watchdogs on site. And one is a steel fixer that should be always on slab. During working, there are chances binding wires may break, or there may be spacers which will dislocate themselves or crush. There are so many issues. So a person from a stillman should be there to remove all this kachra pachra and correct all these dislocations And also there should be someone, carpenter, fixed shuttering carpenter, blow pour slab, who keeps a watch on props or on so-called here in our country bullies, though I don't like it. Means there can be any accident. There can be due to force, due to pressure of pump, concrete fall, beam side can open. There can be unbalanced pressure due to people are standing on one location on slab. Some are here, some are there, some is here, load is there, piling up of concrete is there. They can be anything. People don't care. Piling of concrete is on slab itself, which creates pressure on slab, on form, and it can lose. People don't care in this case. In a haphazard way, sometimes they come and pour here, okay, then pull it, Such operations can lead to accidents. That must be avoided. This means you require continuous attention of foreman, continuous attention of supervisor, as well as continuous attention of engineer. Engineer means site engineer. Slab can get you behind bars if it fails during pouring. There can be failure of formwork. There can be failure of formwork system. There can be failure of whatever. It can lead to accident, and you have to face, you have to encounter losses of human resources and material resources. That is therefore very important. Don't take it too easily. Here everybody is guaranteeing. In our country, everybody is ready to take responsibility without understanding what should be responsibility. So this is purpose warning to you that don't take it lightly. No work is so simple as we think. We cannot leave it to carpenter or to mason or someone. I'll take care of this. Never, never, and never. Because work is work. There, of course, they know practical work. They can do for you, but they need some watch on you. They need somebody should tell them, oh, you're doing wrong, don't do this. And that is purpose of method statement, that we have to give in writing ourselves. We have to give to our supervisor what we are going to do. And if both are on the same page, both person who is doing it and who is supervising it, it can be moved with both eagle eyes of consultant and contractor. You can get so-called professional work delivered. Then so I said engage a steel fixer on slab form and carpenters to look after this location or repositioning of spacers, means concrete spacers. And when I say concrete spacer, this means concrete covers. Don't confuse otherwise. Spacer is a technical word. Spacers because it allows to space bars positions. And also chairs are there for upper layers. That upper layer is supported by chairs, not by spacers. Engage a steel fixture. Okay, it says spacers and binding wire and loosening props respectively during concreting on prepared and approved works. After that, arrange for items as included in checklist and be available at time of inspection as those included in request forms. Now I'm giving some information about what we should have done actually. Sorry. Checklist shall include ready mix or mixer on site, pump or tower or mobile crane. There can be tower crane, there can be mobile crane, depends upon how you are managing your site. Water and hose pipes, pumps, concrete vibrators 1.5 inches and 1 inches, and also standby compressors, wheelbarrows according to requirements. hand shovels, concrete dumpers, trolleys. When concrete is to be transported from site, measure concrete skips, teeth, hand shovels, Haitians, Haitians impregnated in water drums full of water, polythene rolls, handy plastic buckets, wire brushes, spirit labels, artisans' tools for masons and for carpenters, steel fixers pliers, slump cone arrangement, cube, 6 numbers or more, concrete thermometer, weather thermometer and weather measuring tape. So you have to make sure all, once again I read, these are technical tools, you can say, or supports. Checklist includes ready mix or mixer on site. If you are not using ready mix, you have to using a site mix, calibrated site mix. Pump or tower or mobile crane, water and hose pipes, pumps, concrete vibrators, standby vibrators, compressors, air compressor I have to say, wheelbarrows, hand wheelbarrows, according to requirements, hand shovels, concrete dumpers, trolleys, when concrete is to be transported from site batches, concrete skips, teeth hand shovels, Panji you call it teeth hand shovel, Asian impregnated in water drums full of water, polythene rolls, handy plastic buckets, wire brushes, spirit levels, artisans' tools for masons and for carpenters, steel fixers, pliers, slump cone arrangements, cubes according to requirement, thermometers, thermometers for weather and for concrete, measuring tape, etc. Now make a start and supervise every operation to specifications of concrete, laying and maintain all records, taking slump, temperature, cubes, transportation time of transit mixer, etc. and all shall be entered into concrete record register, tabulating as per number this, section, grid, floor, element, quantity and concrete grade, temperatures, slumps, time of concrete, arrival, time of departure of transit mixer, pore placement temperatures, 7th day and 28th day cube compressive strengths, remarks of laboratory technicians, remark of consultant structural engineer, details of supply invoices or dockets, source of supply, date of form striking specifically date on which form is struck, date on which curing stopped, details of disputes in concrete elements, results of hammer test or static load test or any other test as demanded by engineer or resident engineer and all other information site agent and engineer, resident engineer deem fit to be included for specific references to be used by future inquiry commissions during miscarriage of structural elements or structure as a whole. Maybe you people are thinking what I'm telling about. These are all professional activities. I repeat it because this is too significant, you have to make a start and supervise that work, every operation of that work, and that must be in compliance to specification of concrete laying and maintain all records. You have to do it, and that is taking a slump, temperature. A slump means a slump of concrete, temperature of concrete. You have to take cubes. You have to write the transportation time of transit mixer from batching plant to your location, and all are required to enter onto concrete record register in proper table, and you have to write pore number, section number, pore number, whatever it is, section, this section it is, which grid or floor it is, which element quantity and concrete grade, element quantity and concrete grade, temperatures, slumps, time of concrete, arrival time, time of departure of mixer, pore placement temperatures, then 7th and 28th day cube compressive strengths, remarks of laboratory technician, remark of consultant's structural engineer, details of supply invoices, source of supply, date of form striking specifically, date on which form is struck, date on which, when I say form is struck, this means form is removed. So that date is very important, which day you concrete and which day you have to remove that form. So that's the struck, I'm writing striking, so date on which form is struck, date on which curing stopped, details of disputes in concrete elements, results of hammer test or static load tests, or some other tests as demanded by engineer or resident engineer, and all other information site agent and engineer or resident engineer deem fit to be included for specific references to be used by future inquiry commissions during miscarriage of structural elements or structure as a whole. After that, clear all latents and spread saturated Hessian. Once you have done pore, clear all latents and spread saturated Hessian and polythene or curing compound, clear site for 12 hours after you do it. If you have used curing compound, cover it with polythene sheet. After that, inspect surface. Go to site, clear everything first, then inspect surface next day and visually examine formation of cracks if certain. Generally, there should not be, because you have used curing compound and covered by polyethylene membrane. If considerable cracks are found, discovered, contact resident engineer for further inspection and advice. Minor hair cracks do not create major problem. Grout cracking surface with recommended resin by standard pumping of chemicals or some other remedial measure as agreed in this situation. Cure well and construct upstands if so required. Carry out works of columns from first floor to second floor. Now that is next one. Now this slab which you have laid and now you have rectified cracks also, you have to cover with, because already used curing compound, but curing compound shall work only for 1 day when you are doing all this. After that, because you have to move more activities on that, you cannot still depend upon curing compound on horizontal surface. That is only supportive management. Curing compound on column surface and vertical surface, fine, it works. But as far as horizontal slabs is concerned, You cannot depend upon curing compound. So when you walk on surface, people work on that, it will be eroded. It will not stay. So you have to cover with gunny bags, or we call it Haitian bags, saturated one, and put polythene sheet on that for purpose of curing. And if that is not possible, keep spraying water all time and work on columns. That's only way. You may ask question why I am using curing compound and at the same time putting water. Yes, you have to do it. Remember, this is concrete. This is neither yours nor mine. If it fails, you know what happens. There is no solution if concrete fails in test of compression due to lack of curing. And generally, it fails. It fails. I have personal experience of slab failure only because of curing. People do not understand value of curing. They convert good concrete into soil without doing curing. There's no solution. No applied heat treatment. Nothing. Because curing is soul of concrete. Some people used to call it something else. If you miss it, you miss slab. It shall fail certainly. And if it fails, what shall you do? You'll say, okay, I test, hammer test I conduct core drill test. Conduct. If core fails, then what is solution? You have to be scared by that. You are engineer, of course. You may be engineer of whatever highest position, whatever highest degree you have. But concrete is not for you. Concrete is for building. You cannot help it because you have gone contravening specifications, and you cannot restore concrete. Remember, it cannot be restored. It's lost. This is very important point. No solution at all. No doctor can treat it. The only way is demolish it or dismantle it and do again. So you have to compare cost of curing or cost of this risk. This is up to you. And this is only up to you because you won't be there once it fails. You'll be thrown out. Reputation is gone. Material is gone. Money is gone. Time is gone. And you are gone. You won't get another work. Your contractor will not get the work. And that engineer who supervised it, he will be off. But that person is also responsible. We say you are not responsible on papers, but responsibility is. So you are sleeping. When this contractor was sleeping, you were sleeping too. Why did you not go and kick him? We use such language in such cases. You have to teach people a lesson. Consultant doesn't know God. He has to do his part of job and contractor to do his parts of job. Ultimately, destination is work. And if you fail, means we fail. And that's all. I'll take up remaining tomorrow. Already 3 hours over. But my purpose was to keep juniors and those freshers and those budding who are moving towards advanced field to improve their knowledge, which they did not get in from their university. Practical knowledge I did not have a chance to learn because in my time there were no books as such, no talks as such, and I had to learn from books, from specifications, and you can say codes, national decisions of other countries, We don't have such specifications in our country except rubbish specification of government. So I just wanted to share with those who don't have this privilege to learn more and more in contracts on technicalities. And if you can learn it, you can use it. You can act smart. No one can teach you in the field because everybody remains busy. And who has got interest to teach you? Workers cannot teach you. You can watch what they are doing, but they will do only right when you tell them do this. If you don't instruct them, they won't do that because they will work their way. They will give excuse of every activity they don't want to do. This is their, of course, workers. Physical work. I can't blame them too. They are tired. You see, you do in their place. You work on vibrator. You work on jackhammer. You work on these throughout 8 hours. Of course, you would also respond in the same way. They are workers, laymen. You have to teach them. You have to train them on all activities. Yes, once you train them, they can make good crew and they will continue. Otherwise, they will do that. Of course, they need money. Everyone wants some money, some benefit that you have to provide. But you can do that only when you train yourself. This is age of self-training. This is age of self-development. This is age of self-study. College study is limited because professor who teaches is also having limited knowledge. Whatever highest degree you must be having, that is also limited. You cannot exclusively depend upon your college professor, university professor, because that person does not have any field background. PhD he must be having, but he is not having practical work. He is not having difficulties what we face on sites, on works and designs and construction. That person is theoretical, limited to syllabus, nothing else. It's not criticism, it's fact that he has his own job. Professor has his own job, our job is always new. We move in field, we always get different type of projects, whatever sorts of project, hydraulic structure, building structure, canals, or whatever it is. Every design is different. Every specification is different. Everything is different. So you have every new project means every new design. It's not university degree. The same thing you have to learn every year. Here you have to learn new every year. This project is one, you have to hunt hundreds of specifications. Other project you have to hunt again 100. If there's no repetition of same, so you have to make yourself better person, better professional. This is only my purpose, that do not compare with your degrees. You have to understand and then document it, because documentation is very important in this age. Management says you have to document your work. You have to document what you have done. And then you have to photograph, you have to videograph your work. This is also a requirement. You cannot run away. You have to immerse in your profession if you want to designate yourself professional. And if you no, I'm just living for sake of living, eating and drinking, I can't help it. With this, I like to close today's talk with all your. Thank you very much for your kind attendance. Dhanyavad. Thank you.